So in this example, it says, a college math teacher claims that students in her class will score higher on the final exam of the course than students in a colleague's math class. The mean math score for 49 students in her class is 72.1, and the standard deviation is 4.8. The mean math score for 44 of the college students is 69.8, and the standard deviation is 5.4. At alpha equals 0.10, can the teacher's claim be supported? So before we start, I'm going to ask that you write the hypotheses out, and then we'll compare our notes. And the hypotheses I got are the following. The mean for class 1 is greater than the mean for class 2. That is their claim. That would mean that the mean for class 1 is less than or equal to, once again, the equality is in the null hypothesis. And as a result, this tells us that this is going to be a right tail test. Right, so it's going to be a right tail test. So second, let's put together our critical values. And I'm going to draw my curve with the critical value on the right-hand side. Here's the critical region or the rejection region. And we need to find out what is the z-score based on alpha being 0.01. Sorry, 0.10. So we know that from half onward is 50%. That would make this 0.4000 from there to there. So we're going to go into the Z table and find the area for 0.4. Now, when we do this, make sure that you go, if the value of 0.4 is between two values, we're going to go with a higher z-score, and that actually makes it preferable in terms of doing the test. That means that the fence is actually pushed further out if we had to use the larger of the two values. So keeping that in mind, see what you come up with for your z-score. I meant to say Z critical value, not z-score, critical value. So 0.4, if you go to a table, 0.4 is in between these two values here. And so I'm going to go with the higher of the two values, and 1.29. So our critical value is 1.29. Okay, so 1.29 is what I'm going to put here. And next, we're going to do the test. Okay, to figure out the test score. So once again, Z is equal to the mean, sample mean. We're using sample mean of 1 minus the sample mean of class 2 divided by the square root of the standard deviation for class 1 squared, or the variance, that's known as the variance, divided by the sample size of class 1, variance of class 2, divided by the sample size of class 2. Based on this, see what you come up with, and once again, we'll compare our notes. So putting the values in, I have the following, and then performing the calculation, I get 2.3 on top, divided by the square root of 1.13293, 1354, which then gives us 2.3 divided by 1.06, 439, 2481, and almost there. This then gives us a final value of 2.16. 2.16, 0.85, 7.053, and that rounds to 2.16 for 2 decimal places. So plotting that into our curve up here, 2.16 is in this region here. And you can see that it's in the rejection region, which means our decision would be to reject. We're going to reject our null hypothesis. We're going to reject our null hypothesis. And we're going to say that this is what we believe to be true, that the mean of her class is in fact greater than the mean of her colleague's class. So state the conclusion, pause the video, see what you come up with, and we'll compare our answers. My final conclusion, it says, the sample data indicates the mean population class score of the teacher making the claim is significantly greater than the mean score of her colleague's class. That said, you should be able to handle the homework. I think we've done a good handful of examples. Once again, just make sure you go through the process systematically, and make sure that when it comes to putting your hypotheses together, that you do have them correct in terms of whether it's right tail or left tail. So make sure you read the question carefully. Yeah, if you follow these steps, you should have no issues performing this part of the material. Good luck, have fun. If you have any questions, make sure to reach out.